Hey, good morning, everyone. Very good morning. Are you able to hear me and then see my screen? Can you just confirm? Any of you? You can type in the chat window. I hope yes. Yes? Okay. Thanks. Okay. So we will start in a minute or two. Okay. So just take 2 minutes and then we will start. I think we'll be able to start, right? So the time for the session today is 10 o'clock. And it's just 10 o'clock, at least in my laptop clock, right? It's 10:01. And I'm guessing that um, some of the participants are still trying to join the webinar. So maybe we could give them a minute and then we can start, right? I hope that's okay with everybody. Yes, thank you. So I guess I have given enough time and we should also consider those people who have joined on time, right? So let me quickly introduce myself and then we will actually get into the topics, right? So the best way probably to talk about myself will be from my LinkedIn profile. So I'm going to pull up my LinkedIn profile. If you give me a moment. Yes. So my name is Raghu Raman AV. You can just call me Raghu, right? And just call me Raghu. And to talk a little bit about myself, I have about 16 years of experience in the industry. In those 16 years, around 10 years actually falls into big data. So the reason that we are here is to learn big data, right? So I started working with big data in 2010 onwards, almost, right? And I started as a big data developer. I was working on different platforms, including Apache Hadoop, then Spark, Pig, Hive, etc. And over the period of years, I was also fortunate enough to learn a couple of other technologies on the way. For example, a little bit of machine learning and cloud computing. So I don't call myself as a data scientist or a machine learning engineer, right? But since there was some requirement, I was sort of like inclined to learn a bit of machine learning, okay? And then cloud computing. So by around 2015, most of the workloads were migrating to the cloud. So my company also wanted to migrate our day-to-day activities to the cloud. And that is how I got introduced to the cloud computing, especially Amazon Web Services. And I also used to handle big data on Amazon Web Services, right? And also in the past decade, I was fortunate enough to work with one of the biggest companies in the respective domains. I was closely working with this company called Flipkart, right? E-commerce company. So I was working as an external consultant for Flipkart for 2 years, wherein my role was actually dealing with their big data platform and migration problems and all, right? So one of my client, which most of you will know, is Flipkart. And then I have been working with a bunch of other companies, including GE, that is General Electric, Bank of America, then Fidelity, EMC Square, Cisco. So these are some of my clients where I used to work with them. By around 2015 or 2016, I quit my full-time job. I started working as a consultant. So now mostly what I do, there are two aspects of my job these days. I don't work full-time, but what I do mostly, I'm into consulting. So I help companies to move to the big data domain. So some of the companies, they take my help in designing their big data platforms, migrating their workloads to big data, etc. That is one part of my job. The other part is just like we are here. I enjoy teaching people or training people, and training is another aspect of my job. So I have been closely associated with a couple of universities in India and abroad, and there I have been delivering programs on big data, visualization, etc. So that is a quick intro about myself. I think we should be talking more about the technology than about me in the class, right? So my intro is fine, but I guess the discussion should be around big data, right? Okay, so what do we have? I think you guys have already gone through one class where there was an introduction to big data, right? Am I correct? Did you guys go through an introduction to big data class? I suppose you have went, right? What was the last class about? I think it was introduction. Yes, and in the last class, did you guys learn about Hadoop, or was Hadoop discussed or mentioned in the last class? No, Hadoop was not discussed. Only big data was discussed, right? Only there was a discussion on big data, right? No Hadoop. Okay, great. So great, no problem. So today what we are going to do, we are going to start the discussion around Hadoop. And you have to also understand that the entire curriculum that we have, these 12 hours of curriculum, will give you an overall overview of all these tools and technologies. So this is kind of like an introduction course to big data, right? Where my role is more or less to introduce these tools and technologies to you, probably show you some examples as to how these tools are being used, and guide you towards that. So today we will talk about Hadoop. And since today the discussion is around Hadoop, see, I'm not really a slides person, okay? Yeah, so PowerPoint slides are really good, but in my classes, usually in some of the classes, I prefer the slides, but in some other classes, I would like to explain by drawing and discussing and writing. So today, probably we will skip the slides, right? So slides are actually very boring, right? Let's see what exactly is Hadoop. Okay, so I'm just gonna open a website, hadoop.apache.org. Apache Hadoop. So all of us understand the big data problem, right? What is the big data problem? First of all, you have huge amount of data, right? I have probably terabytes and petabytes of data, huge amount of data. And I would like to store it somewhere. First problem, right? Now, can I use the traditional tools and technologies to store them? I can, but the problem is they're really costly, right? So if you're talking about a database or a data warehouse or even a server, you can definitely store the data. But the problem is, I not only want to store the data, I also want to analyze the data. So when you think about a platform where you can store and analyze data, some of the things that comes into your mind is platforms like RDBMS, for example. But RDBMS is not going to solve my problem, my big data problem. Why? Because first of all, RDBMS has some limitation. See, you can probably store 100 gigabytes of data or maybe 1,000 gigabytes of data. That's 1 terabyte. But if you have 1,000 terabyte of data, where will you store? RDBMS will not support those level of sizes if you talk about it. So my first problem is I have this ever increasing data. I want to store it and I don't see any solution in the traditional world. That's my point number one. Point number two is that the problem gets more complicated because I have structured data, semi-structured data, unstructured data. So if somehow you convince me saying that, okay, you can use an RDBMS or a database, the problem here is databases usually support structured data, like rows and column, table format, right? So if I have data in the form of Excel files or CSV files, well, I can store in RDBMS, no problem. Or probably the data coming from web applications, I can store it. But what if my 1,000 terabyte data is a combination of, let's say, text, image, video, audio, binary, everything put together? How do you store it? I don't know. Honestly, I don't know. So first problem is the size. You have huge data. The second problem is you have complex data. That is what we call complexity of the data. The third problem is you could have probably went through this. I don't know, something called velocity. Velocity means the data keeps on growing. To give you an idea, I was working with the Flipkart, right? So I can just give you some some thoughts on what we were doing, right? So here Guruvinder was saying that we store image, email on database as well, like S3. True, I agree. You can store it, right? But then processing again becomes a challenge, right? So that is what I was saying. Not only storing is the problem, processing also becomes a problem. So when you want to process the stored data, you need frameworks which can understand how the data gets stored. Yeah, definitely that is a good solution. I can go to cloud and all, maybe use Amazon S3 or Azure Blob Storage, these kind of platforms, right? But let's see for an example. And then the next problem that I have is something called velocity. Velocity basically means the data keeps on growing. It never stops. Like when I was working with Flipkart, right? Every day Flipkart used to collect close to 200 to 300 terabyte of data every day. So your problem is every day I'm getting, let's say, 200 terabyte of data. It never stops. So you cannot find an end to this problem, so it always keeps on coming, the data keeps on coming. So that is where way back in 2005, this framework called Hadoop was created. So Hadoop was actually created in 2005, long back, right? And whenever you Google for big data or search for big data, you always find Hadoop along with it. So a lot of people ask me like, why Hadoop is so popular, right? See, the reason why Hadoop is so popular is it was one of the first platform which was able to store and analyze big data. So 2005, which means almost 15 years back, right? So 15 years back, or I can say way back in 2005, two people called Doug Cutting and Mike Caffarella, they created this framework or platform called Hadoop. Okay, and their intention was very simple. Hadoop was supposed to store big data, no matter whatever is the size. It should also give you an idea or an option to analyze big data. So Hadoop's original design principle or design goal was a platform which can store unlimited data, which should also provide you analysis tools on top of that. And it was created in 2005, like I said. And very soon, Hadoop became popular because a lot of companies had this problem way back in 2005 or 2007. For example, some of the companies like Yahoo and Facebook, they were starting to realize this problem of big data. You see, if you look at Facebook as an example, Facebook had this big data problem, but they were using Oracle at that point in time because Facebook did not know what to do, right? So all the data that Facebook was collecting, they were cleaning and they were creating structured formats and they were dumping in Oracle because that was the only solution they had. So when Hadoop was created, immediately Yahoo acquired it. So Hadoop was actually created by two people called Doug Cutting and Mike Caffarella, and they were working for a startup company. Okay, so Yahoo immediately realized that this is a very powerful platform, and Yahoo hired these guys, Doug and Mike. Okay, and then Yahoo said, okay, you can develop Hadoop by sitting inside Yahoo, and they made Hadoop better. But very soon, Yahoo did one good thing. Yahoo realized that Hadoop is a great platform, but everybody should get the benefit of Hadoop. So what Yahoo did, they open sourced Hadoop. It became an Apache project. So Apache is this open source foundation, right? Apache Software Foundation. So the source code of Hadoop was open sourced to Apache. I think this happened around 2006, right? From there onwards, Hadoop is an open source project. However, you should also understand one more thing. Now, we will look at the architecture and other things, don't worry. But when you say Hadoop is open source, nobody uses open source Hadoop in production. Okay. So this is like saying Android, right? So I'm quite sure that at least some of you might have an Android phone, right? What is Android? Android is an open source project. But do you really have an Android phone? No, no, right? See, you have a Samsung phone or you have a Sony phone, I don't know, or Xiaomi phone or some other phone, OnePlus phone. So what is Samsung, OnePlus, Sony doing? They will take the open source Android, modify it, put it in their platform and sell it to you. You never get the vanilla, what you say, or original Android. I think it is available on the Google phone, but even that is not really vanilla. So very similar to that, even though Hadoop is an open source project, Apache project, right? People don't use Apache Hadoop in production. People use a vendor specific version. So one of the most popular company which sell Hadoop is called Cloudera. So Cloudera is one of the vendors of Hadoop. Basically, you can go to Cloudera and say that, hey, give me Hadoop. So they will install Hadoop in your company or wherever you want with technical support, right? So they will charge you for technical support. They use open source Hadoop, but they are selling it as a product, just like Samsung is selling an Android mobile phone or anything like that, right? So even though Hadoop is open source, the source code is being contributed by thousands of developers around the world. It's highly unlikely you use it in production as open source. That's one thing. And Cloudera is not the only vendor. Cloudera is the most popular vendor. There are many other vendors for Hadoop if you want, right? And the second point you need to understand is that Hadoop is more or less like a platform. It's not a software, it's not a tool, even though I have been saying that tool all the time, Hadoop is not a software or it's not a tool. It's more or less like a platform. I would like to call Hadoop as a platform. What do you mean by a platform? A platform means it is a place where you can install other tools on top of that, right? Again, comparing this with Android, we always say Android is a platform because once you install Android on a hardware, Android will allow you to install other tools on top of that, right? Android is the operating system, but then what happens? You can install applications from Play Store. Basically, they get installed on top of Android. So how many applications are there which you can install on Android? Millions of them. So similar to that on Hadoop, we don't have millions and all, but hundreds of tools you can install on top of Hadoop. We will see that. Okay. Now, it's really important to understand the architecture of Hadoop before we proceed further, right? So I just told you that Hadoop is a platform which will help you to store and analyze big data. Yeah, that's just the definition, right? But how is it possible? How is it actually helping you to store and analyze big data? It's rather simple. See, traditionally, what people do is that if I want to, let's say, store anything, I always depend on a single machine, right? It can be a laptop, it can be a desktop, it can be a server. So let us suppose you have a server, just to give a simple example, okay? I have a server, and on this server, let's say you want to store data and probably analyze the data. The problem here is if you're taking a single machine, there is always limitation. For example, if you take a server, you can say that I can have 16 GB RAM. If that is not enough, you can upgrade. You can go to 32 GB. If that is not enough, you can go to 64 GB. But there will be a limit. Every platform based on the motherboard will have a limit. So this server, let's say the maximum RAM is 32 GB, which means you cannot go beyond 32 GB. Also, when you look at hard disk, okay, which you put inside a server, there is again a limitation. Maybe you can add a 1 terabyte hard disk, 10 terabyte hard disk, maybe 20 terabyte hard disk, I don't know. But maybe it is not possible to add beyond 20 terabyte. So the idea is if you're using a single machine, you always have limitation. Logically thinking, you can understand that on a single machine, I cannot store big data, right? Single machine means it is limited. So what we do in the world of Hadoop is we go for something called distributed computing, meaning rather than taking one machine, we take a bunch of machines. So let's say 1, 2, 3, 4, just an example, okay? So let us suppose that you are having 4 machines instead of one machine. And let's say each machine, suppose, has a 10 terabyte hard disk. So each machine is having 10 terabyte hard disk. Now, when you install Hadoop on these machines, I'll talk about architecture in detail, but let's say you install Hadoop, and when you install Hadoop, you install it in all the machines, by the way. But when you install Hadoop, what is going to happen? Hadoop can combine the storage of all these individual machines into a single storage pool. So basically, you're getting 40 terabyte here. So rather than looking at one machine with 10 terabyte of storage, now you are saying that, hey, you know what? I have 4 machines and I can get a total storage space of 40 terabyte. This is one thing Hadoop can help you to do. So this is what we roughly call distributed computing. Distributed computing basically means you are using more than one machine connected And this is what you call a cluster. The technical term for this is called a cluster. What is a cluster? Cluster is nothing but group of computers. Okay, so in the world of Hadoop, what we do is that we take bunch of machines, install Hadoop in them, so that Hadoop can utilize their individual, what you say, storage capacities to give you a single storage pool. Now, this is just an example, meaning this is like 4 machines. A Hadoop cluster can scale to any limit that you want. You can start with 4 machines, go to 40, 400, or even 4,000 machines. There are Hadoop clusters in the world which run with 4,000 machines. Very common. So imagine if you have 4,000 machines, each with 10 terabyte of hard disk, what is the capacity that you're talking about? And the beauty of Hadoop is not this. The beauty is you can always scale up and scale down on the fly. Meaning, if you have 4 machines, without interrupting your production, you can add one more machine. You can add one more machine. So you are able to resize the cluster. You can add more machines, remove machines without stopping the cluster. So you get an elasticity here. This is called elasticity. Your storage practically become elastic. So you may be naturally wondering how it is able to like combine the storage. I'll come to that architecture, okay? But I'm just giving you some idea before we dive into the architecture. So the first advantage is in the storage space. Now, so let us suppose you are storing the data. Storage is one problem we have in the world of big data, right? One challenge we have is that, hey, how do you store? You know, how can I store huge amount of data? The second problem is, okay, I'm able to store the data, no problem. How do I analyze the data? How do I analyze the data? So if I want to analyze the data, Hadoop can provide resources of the same machine. To give you an idea, let's say this machine is having 16 GB RAM. Okay, this machine is also having 16 GB RAM. This is also having 16 GB RAM. This is also having 16 GB RAM. Hadoop can also combine the RAM and CPU of your machines to do parallel processing. The way Hadoop usually processes the data is that it will divide your processing parallelly. To give you an idea, let's say there is some data here and some data here and some data here, and let's say some data here. So you have 4 pieces of data. Each machine can process the data that belongs to that by default. So you're doing something called parallel processing. You are not saying that, okay, let one machine process all the data. You're saying that let all the machines do parallel processing. So this will be facilitated by Hadoop. So this is why Hadoop is a practical solution to your big data. So your storage is distributed, meaning the storage is lying on multiple machines. The processing is also distributed. When you want to process the data, that is also distributed. It is not like one machine is processing the data. You know, all the machines are part of the processing. However, there is also one more thing which you need to understand. We are trying to give only an introduction to Hadoop, so probably we will not go deeper into that. But see, your traditional processing will not work here. Meaning, let's say you wrote a Java program, it will not run on Hadoop, not possible. Or let's say you wrote a Python program, cannot work on Hadoop. Because usually when you write a program, any program, okay, no matter any program, let's say Java, Python, any kind of program, what happens is that the program will assume that the data is in a single machine, right? So if I wrote a Java program and I run the Java program on my laptop, it will work beautifully because the data is in my laptop, the program will read it, program will process it. That's it. But when it comes to Hadoop, if I write a simple Java program, it will fail miserably because My Java program has no idea what is a cluster, what is distributed computing, where is my data, is it in one machine, is it in two machines, it will fail to understand. So in order to process the data on top of Hadoop, you need to use specific processing engines. That is the catch, right? So I can store big data on Hadoop, no doubt about it, right? But when I want to analyze the data, I have to use tools which will work with Hadoop, tools which understand Hadoop, tools which understand distributed computing. I cannot write a normal program and say, okay, let it process. No. These processing engines are what some of you could have heard about. There is something called Mapreduce. So Mapreduce is a processing engine. Spark is a processing engine, etc. So these are the processing engines on top of Hadoop. These guys understand Hadoop. They know how the data is. And these guys can do distributed computing, distributed processing. They can take 100 machines and run processing parallelly, which is not possible for a normal Java program. So when you want to analyze the data, the processing engine should also be distributed. The processing engine should understand how to pick up data from 4 machines, run it in 4 machines parallelly. So these guys are called your Mapreduce, Spark, etc. I mean, I'm just giving an overall idea. We will go into the deeper architecture, but this is basically what is happening in Hadoop. Now, in most of the online articles or training videos, or when you read about Hadoop, it will be written that cost is a problem. And I understand. See, in big data world, one of the biggest problem we have is the cost. And that is the reason every company is looking for new solutions. See, I need a solution to store, say, 1,000 terabyte of data or 10,000 terabyte of data. So 1,000 terabyte is technically 1 petabyte. Okay. So 10 petabyte is 10,000 terabyte. So let us say you want to store 10 petabyte of data. Fine, we can do this. But the real question is, how cost effective is your solution? To give you some example, there are companies like Teradata. So there is a very famous company called Teradata. Hey, how come Bing became my default search engine? I hate Bing. It's probably the worst search engine ever invented in the world. I should change it actually. See, it's not even able to find the right website. Yeah, I think I found it anyway. Great. So Teradata is one of the companies in the world. It is a data warehousing company. It's not a Hadoop or anything. Teradata is one of the leading data warehousing companies in the world. Maybe some of you have worked on Teradata. I don't know. Some of you are familiar, right? So Teradata will say that, okay, you know what? You want to store 100 terabyte, 1,000 terabyte. We will help you to do it. No problem. In fact, many companies use Teradata or used to make use of Teradata. So Teradata is a data warehouse. Okay, it's not Hadoop or anything, but they tell you that we can solve the big data problem. You give us any size of data, any kind of data, we will store it and help you. True, I agree with them. But what is the problem? Their charges are so high. First of all, Teradata supports millions of dollars only for support. Second thing, their platform also requires a lot of money. So the challenge here is that we have many platforms to store and analyze big data. Probably Hadoop is not the only platform, but when you look at platforms like Teradata, they are highly costly. So a normal company probably cannot afford Teradata, right? Because it is so damn costly. In fact, we have many customers who are using Teradata, and partially shifted to Hadoop. The beauty of Hadoop is, you may be wondering that then how Hadoop is cost effective, because you are saying that a cluster is like 400 machines. So a production Hadoop cluster is something like, let's say 400 machines. over 500 machines. How are you saying 500 machines are cost effective? Because you need to buy these machines and then, store the data. So you have to spend a lot of money for these machines, hardware, right? How do you say it is cost effective? See, that is where the real catch is. Hadoop says you can use something called commodity hardware. It's called commodity hardware. So what Hadoop says is that if you want to create a cluster, right, don't use costly servers, use something called commodity hardware. What is commodity hardware? Nothing but assembled or cheap machines, right? So in a Hadoop cluster, you are not going to use costly servers. Now, I have worked in the server industry for some time, way back in 2013 and 14 and all. But I think even now it is almost same. If you look at an IBM server, if you really want to buy an IBM server, right, a blade kind of server, it'll cost you like 5 lakh to 7 lakh rupees, right? And that is so damn costly. So in a Hadoop cluster, if you're buying 500 IBM servers, that will be like crores of rupees. You don't want to do that, right? So what you do is that instead of buying, let's say, an IBM server, you buy an assembled server. So these machines which we use in Hadoop, they just need to have a RAM, processor, and hard disk. They need not be branded machines. That is the way you reduce the cost. Hadoop can support that. The flip side of that will be, any machine can go down at any point in time. Since you are using assembled or non-branded machines inside your Hadoop cluster, any machine can crash or go down at any point in time because there is no reliability for these machines. But Hadoop has internal mechanisms to fight data loss. I will talk about it. So when you're building a Hadoop cluster, you are not really going to use costly hardware. That way, the pricing is reduced so cheap. I still remember once there was a company where I went for consulting, and they had a 100-node Hadoop cluster, and they were using this refurbished server. You know what is refurbished server, right? Like it is like used car. So if you go to the Maruti showroom, right, you can buy used cars from Maruti. But what Maruti will do, they will buy second-hand car and modify that. They will correct all the problems, polish the car, fix everything and resell. That is called refurbished car. So very similar to that, we get something called refurbished servers, which the company was using. And I asked them like how much it cost you. Each server was around 60,000 rupees. So cheap, right? 60,000 rupees means for a server you're talking about, and they were using that. So the hardware you're using inside a Hadoop cluster is really cheap. So you're not really using costly branded hardware for this. Okay, great. So now we can talk about another important concept, which is when somebody asks you, what is Hadoop? We always say that Hadoop is a combination of storage plus resource management plus processing. So when you want to define Hadoop or the architecture of Hadoop, you always say that Hadoop is a combination of storage, resource management, and processing. So there are three components for Hadoop. There is a component which manages storage, there are components which manage processing, and there are components who manage resource management, right? Three types of components are there for Hadoop. So when you want to discuss Hadoop architecture, right? Okay, so Monica was saying, can you please increase the font size? Oh, I think you're joining from a mobile phone, right? How do you increase? I'm using Notepad++. Hey, where is this increase option in Notepad++? I never, or maybe I will use normal Notepad, right? Do you guys know where is the increase option? or Notepad++. Maybe I'll use Notepad. Sorry. Let's use normal Notepad. And let me say the font size is a little bit bigger. Yeah. So what I'm saying is that I'm saying that Hadoop is a combination of these three things. Yeah. So when you say Hadoop, it has storage, then it has something called a resource management. Then it also has something called, there is storage, resource management, and then a bunch of processing frameworks. This is what we have, in Hadoop. So when somebody discusses the Hadoop architecture, they usually discuss these things. And let me give you an idea about them. So what about storage? So let's look at storage first, and then we will come to resource management, processing, and all. What about storage? See, the storage of Hadoop is handled by something called HDFS, and this stands for Hadoop Distributed File System. HDFS stands for Hadoop Distributed File System. What is this? See, Hadoop Distributed File System is nothing but the storage component of Hadoop. So how storing of data works in Hadoop is, to give you an idea, so let us suppose that you have created a Hadoop cluster, and Hadoop always follow this master-slave architecture. Okay, so whenever you are installing a Hadoop cluster or creating a Hadoop cluster, it always follows this master-slave architecture, which means one machine will be running as the master, the remaining machines will be running as slave machines. So let us assume, for the sake of discussion, that you created a Hadoop cluster and you have 3 slave machines, 1, 2, 3, and 1 master machine. So all of them are servers only, nothing else. Okay. So in your Hadoop cluster, total there are 4 machines. 1 machine is the master. The remaining 3 are actually slave machines, slave and master, right? Now, in terms of HDFS, so we are discussing HDFS, right? We are discussing how storage is working on Hadoop. Storage is handled by this guy called HDFS, right? In terms of HDFS, what happens is that there is a process called name node, okay? Name node, it's called name node. The name node process will be running on the master machine. Slave machines will be running a process called data node. I will explain what they are, but every data node is running a process called data node. So I will say DN1, DN2, and DN3. So in terms of storage, when you want to understand Hadoop, the master machine runs a process called name node, and the slave machines will be running a process called data node. So in our example, there is 1 master, so there is 1 name node. Then there are like 3 data nodes because there are 3 machines running as slave. And when you want to store the data, what is going to happen? The data will never get stored on the name node. See, the name node is the master. It is like the boss. It just decides where the data should go, how it should go. It is not going to store your data. The data nodes or the slave machines are the guys who actually store the data. So just for the sake of argument, let us suppose that you want to store a CSV file. So this is your CSV file, okay. Let's say the CSV file is called sales.csv. So you have a CSV file, you want to store it in Hadoop. The size of this CSV file is 192 MB. Just an example, okay? The size of this file is actually 192 MB. So what is going to happen when you want to store this file is that, see, whenever you are storing anything in Hadoop, Hadoop will ensure that the data is distributed. The file is not going to get stored in a single machine. So what Hadoop does is that it will divide this single file into something called blocks. So you have a single file, okay? And that file gets divided into something called blocks. By default, every block will have a size of 64 MB. Well, that's not by default. By default, it is 128 MB, but you can change it. Let's say the block size is 64 MB. So what Hadoop says is that, okay, boss, you want to store a file? Okay, whatever you want to store, please divide the file into blocks of 64 MB. I will not allow you to store it as a single file. So no matter you have a 1 GB file, 10 GB file, 100 GB file, the file has to be chopped or divided into something called blocks. So let us assume that the size of a block is 64 MB. This you can change in the settings. So when you are installing Hadoop, you can actually change this size of this block, what is going to be the size of each block, right? And I'm just assuming that the block size is 64 MB. So what is going to happen? Your sales.csv file, the size is 192 MB. If you divide it into 64 MB, what is going to happen? You are going to get blocks of 3. So you're basically going to have block 1, then block 2, then block 3. Because 192 divided by 64 is 3. So you will end up having 3 blocks. Then what Hadoop will do, it will ensure that each block ideally go to a different data node. So B1 will be here, B2 will be here, B3 will be here. This is how the data gets stored. So the file is divided and distributed, divided and distributed. Any file that you store in Hadoop, this is the way it stores. Any file that you store, it divides the file into blocks. Then each block, it will try to keep in a separate machine. Why? Why are you doing like this? Why can't you just keep everything in one machine? Because now if I want to process my file, now if I want to analyze my file, I can ask each machine to do it parallelly because each machine is having a part of my data. So I can use parallel processing because the data is actually distributed in 3 machines. Not only this, now there will be one confusion. Okay, I told you that Hadoop clusters are actually having commodity hardware, or the machines you are using in a Hadoop cluster are actually cheap machines. These servers are actually cheap assembled servers. So any machine can go down. Any machine can crash. So let's take an example that data node 1 crashed. If data node 1 is crashed, the problem is block 1 is gone. What will you do? Your data is corrupt because your data is a combination of block 1, 2, 3. Now I'm saying data node 1 is gone. That means block 1 is gone, right? Then what will happen? So to prevent this, by default, Hadoop has this idea of replication. Each block is replicated 3 times. So this block 1, it will keep a copy here. Again, the block 1, it will keep a copy here. Block 2, again, there will be a copy here. There is block 2. And one more copy here. Let's say block 2. Block 3, again, there will be a copy here. And one more copy here. So every block is replicated 3 times. 3 times by default. Now, I'm just showing an example because there are only 3 machines. In a production cluster, thousands of machines will be there. So you can imagine the scale actually. So Hadoop not only stores your data, it also replicates your data. So each block is replicated 3 times. So now if my data one crashes, okay, definitely the blocks are gone, but I have a copy, I have 2 copies of the data on data node 2 as well as data node 3. So I can retrieve from there. So you always replicate the data as well. You always, you not only store the data, you also replicate the data whenever you are storing it on top of Hadoop. Okay, so there was one question, let me just check. What if the file is less than 64 MB? If the file is less than 64 MB, it will create a block with the size of that file. Let's say you're storing a 20 MB file. Then what will happen? A single block will be created with the size of 20 MB, and that will be replicated over. That is how it works. Okay, so block size is applicable, standard block size is applicable as long as your data is bigger than the block size, like 100 MB or 1 GB or anything like that. Now, if you look at Hadoop, Hadoop actually has 3 major versions. Okay, so Hadoop has 3 major versions. So there is something called Hadoop 1.x for the 1 version. Then there is something called Hadoop 2 version. Then there is something called Hadoop 3 version. So these are the major versions. You will say Hadoop 1, 2, 3. Hadoop 1 is no longer being used. You cannot get it actually. Hadoop 1, I think people stopped using Hadoop 1 in 2015, long back. So you don't have to bother about Hadoop 1. Nobody uses Hadoop 1. Hadoop 2 is what we are using currently. So the architecture I explained is for Hadoop 2. Okay. Hadoop 3 is actually the latest version. So Hadoop 3, when you talk about it, Hadoop 3 is probably the version which is currently being used. So a lot of companies are actually migrating to Hadoop 3. Hadoop 3 actually got released probably, last year, right? So Monica says, can you unmute me? Monica, unfortunately, I don't have the control to unmute you. I don't have the control to unmute anybody, right? Probably I can check with my colleague, okay? Just give me one moment. Do I have anybody? No, I will do one thing, Monica. I'll just check with my colleague how it can be, unmuted. I don't have the control right now, but I will request for the control. Okay. Now, one more interesting question is, if this is all happening, what is the purpose of your name node? So you have a machine called name node. What is its purpose? You say it is the master. See, the name node's purpose is it stores the metadata. Name node actually stores something called the metadata, meaning the name node knows that the sales.csv file is a combination of B1 plus B2 plus B3. So name node knows that how a file is stored inside your cluster. So whenever you want to read or write from a Hadoop cluster, you have to always contact the name node. Without the name node, you cannot read or cannot write from a Hadoop cluster. Because let us suppose now you want to analyze this file called sales.csv. I want to analyze this file, but I don't know where is the file. Is it on data node 1 or 50 or 100? So I have to always go to the name node and get the metadata. Name node basically stores the metadata. It stores all the files and how they are divided, where is the location, everything is stored by the name node. And also when you want to create a new file or write a new file, you go to the name node, and the name node is the guy who gives you the location. The name node is basically the guy who gives you the location where you will be able to write the data. Okay. So we will do one thing. We will take a break. I will answer your questions after the break. Don't worry. I can see that Monica, I will look into that, and Aditya also has a question. I will come to those after the break. But let's take a break, then come back, and then resume the discussion. So I will write it here so that we are all aware. I will say that we are on break. Let's say we'll resume at 11:10, right? So we will take a break. Meanwhile, if you guys still have some more questions on whatever we were discussing, you can post it in the chat window and I can answer that. Thank you. All right, let me pick up some questions, okay? Aditya was having a question. Is the remaining space in that block wasted, or is it used for some other file? It will be used for some other file. So if you have, let's say, let's say you're storing a 20 MB file, the block size will be only 20 MB. You know, it will not be 64 MB. It will be 20 MB only, because as long as the file size is less than the block size, that will be used. So it will not be wasted, right? Tushar is saying, do we need to configure in how many nodes data has to be stored? No, that will be intelligently decided by your name node. You don't have to know that. Your name node will figure it out, right? Does this configuration and block size differs for all files or data? No, this is a global configuration. The block size usually is a global configuration, meaning you set it up globally. So any file that you store, the block size, it will pick it as, let's say, 64 or 128. It is not going to change from what you say, one to another. So Monica was asking, can you just unmute me? Give me a moment, okay? I will unmute you. I can't see Monica. I think Monica just left during the break, probably will come back. Then we can discuss, no problem, right? Okay, so I guess those were the questions we had, right? As of now. Great. So let's continue. So if you look at our architecture, this is the basic architecture of HDFS, or this is how you are storing the data. No matter any file that you would like to store, Hadoop will internally divide it and distribute it and replicate it. And in order to work with Hadoop, you don't have to really know this. This is like good to know information, because if you are a developer, then all you do is that you copy the data, you run the program, you analyze the data. That's all you do, right? So you're not really concerned about what is happening behind the scenes. Even if you look at your Windows laptop, it does exactly the same. I don't know how many of you are aware of this. When you copy any file on your Windows laptop or MacBook, it also divides it into blocks and stripes and keep it in the hard disk, right? But we are not aware of it, or we really don't look into how it is happening, right? Same way in case of Hadoop as well, this will happen behind the scenes. Great. So now, so the first part of architecture was something called storage. So I told you that Hadoop has three components: storage, resource management, and processing. So storage is handled by your HDFS. That is nothing but a combination of name node and data node. The second part is called resource management. Resource management is handled by something called YARN. YARN stands for yet another resource negotiator. I mean, that is a full form of YARN. Now, you don't have to have an in-depth understanding of YARN. Why? Because YARN is mostly the area of an administrator. So if your job is actually to install the cluster, set up the cluster, you are a Windows administrator, Linux administrator, then mostly YARN is your area, right? But what is exactly that YARN is doing? Okay, so YARN is, it says resource negotiator. What is YARN? So to give you an idea, let's take the same example, right? So I have my master machine here. So this is my master machine. Then I have three slave machines. One, I'm going to draw the same diagram. 2, 3. And for the time being, let us assume you're looking at only the primary copy. I'm not drawing the replica, because then the diagram will look very weird. So I'm just drawing only B1, B2, B3. This is how your data is, right? Now, end of the day, what you want to do, you want to analyze the data, right? So you will be writing programs to analyze the data. So there are many frameworks, execution frameworks. Like I told you, there is something called Mapreduce. There is something called Spark. So you will be writing Mapreduce programs, Spark programs, etc., to analyze the what you say data, right? So when you're writing a program, so let us suppose you wrote a program. We did not come to that part, but when you write the program, who will give you resources to run the program? That is Yarn. So Yarn is nothing but your resource manager. Yarn basically allocates resources to run the program. So this machine is actually running the name node process, right? So this guy is having my name node, and this is my data node 1, and this is my data node 2, let's say, and this is my data node 3. This is how the combination, right? Now, Yarn will be by default part of your Hadoop installation. You don't have to install it separately or anything. Yarn also has a master and slave. The master in Yarn is called your resource manager. There is somebody called resource manager. Slave is called node manager. So I will say this is, so every machine will have the slave. I will say this is node manager 1. This is node manager 2. This is node manager 3. Now, what is the job of Yarn? Let's say you wrote a program and submitted the program to run inside the Hadoop cluster. The program will be accepted by your resource manager, that is the master. This resource manager is constantly in touch with these node managers. Node managers are the slave processes in Yarn. The node managers will understand, or the node managers will collect the resource utilization of every machine. For example, let's say each data node has 16 GB RAM and let's say 8 processors, just to give you an idea. So each slave machine is equipped with 16 GB of RAM and let's say 8 processor cores, right? That is what it has. What Yarn does, it allocates something called containers to run your program. So if you want to process these 3 blocks of data on each machine, Yarn can allocate JVMs on each of these machines. So Yarn is going to say that, okay, in order to run the program, I will give you 3 JVMs on each machine. Each JVM will have, let's say, 2 GB RAM and 1 processor. So Yarn facilitates the resources in the cluster. And accordingly, there will be multiple programs running, right? It is not like in a Hadoop cluster, you are running only one program, right? In a Hadoop cluster, what is going to happen? You're going to run lots and lots of programs. So each program will need some RAM, some CPU from each machine. This will be allocated by your Yarn. That is the primary role of Yarn. It is the resource management framework. So Yarn will monitor all the programs that are running. Yarn will ensure that all the programs are getting enough RAM, enough CPU. And some of the frameworks like Spark, they can negotiate with Yarn for extra resources. So when you're writing a Spark program, Spark can go to Yarn and say that, okay, I want 4 GB for this machine and these many processors, and Yarn will allocate them. So these allocations are done inside a JVM. So this is nothing but a JVM, or you can say it's a container. So your program will run inside this container. It will take the data and analyze the data inside this container. So Yarn is nothing but your resource manager, Okay. And when it comes to processing of data, where is it? The notepad. Yeah. So storage, we looked at HDFS. Resource management, we looked at yarn. When it comes to processing the data, by default, the processing engine in Hadoop is called Mapreduce. So in order to analyze the data or process the data, there can be many processing engines, okay? But if you just download and install Hadoop, by default, you will be getting a processing engine called Mapreduce. Mapreduce is the default processing engine. We also have a lot of other processing engines. There is something called Thais, there is something called Spark, there is something called Impala, etc. So there are many processing engines which you can use depending on your use case, and we will see them, right? But the default processing engine we get on top of Hadoop is actually MapReduce. Now, MapReduce is a processing engine, which means you can write a program using MapReduce, and that program will run inside the cluster, analyze the data, and give you the output. So if you want to use MapReduce to analyze the data, then you have to use a programming language. MapReduce programs can be written in Java, Python, and C#, many languages. So MapReduce itself is not what you say a programming language. It is just a processing framework. You have to write a program in one of the languages to run in MapReduce. Let me give you a small overview about MapReduce, like how you will be able to look at a MapReduce program. So let me take a paint window to talk about it, right? Now, MapReduce is a general processing framework. Okay, so it has been used by many platforms, and Hadoop is just one of those platforms. So do not think that MapReduce is only available on Hadoop. No, MapReduce is a general processing platform. It is available on many frameworks as such. But what is the idea of MapReduce? So I'm just going to give you an example, or maybe I can take an image to talk about MapReduce. You can say MapReduce word count. I can go to images. Let's see which one to pick up, okay? Yeah, this one will be better. So I just need this image. If you allow me, I'll just get this image to talk about. Save image as, let's say we save it in documents. Right. So this is an example of how a MapReduce program can be written and how it can be executed. Now, this example does not really talk about the code actually. It's not a code example. We are not talking about the code because you can use any language to write a MapReduce program. We are talking about how the program execution will happen. So to give you an idea, let us suppose you have an input file. Okay, so have a look at this input file. The input file has some letters, so can I draw? You can draw, right? Let's say the input file is this. So this is your input file. Have a look at this. What is the input file having? The input file has some lines of data. For example, bus, car, train, again, train, plane, car. Then you have bus, plane. That's what you have in the input file. Now, let us assume that this input file is really big. So as of now, you have only 3 lines. But let's suppose this input file has, I don't know, 100 billion lines. And imagine it is stored in Hadoop. So this is like a really big file. Now, you want to do something called a word count program. There is something called a word count program. what is a word count program? A word count program basically allows you to count the frequency of words in the file. So what I want to do, I want to write a Mapreduce program which will tell me how many times each word is occurring in the file. So if you look at here, since this is a very small file, you can easily say bus is repeating 3 times, car is repeating 2 times, train is repeating 2 times, and plane is repeating 2 times. So you can easily say that because it is a very small file. But if you had like 100 billion words, how do you do it? So what is going to happen is that when you write a Mapreduce program, whatever that program is, there are two important components of a Mapreduce program. Let me see if I can change this. Okay, color. Yeah. So there is a phase called mapping. Here you can see. So this is the first phase of Mapreduce. It is called mapping. So you need to write a program called a mapper program or a mapping program. What is the purpose of mapping program? The mapping program is supposed to read your data and produce key value pairs as the output. So to give you an idea, my text file has 3 lines. Okay. My requirement is to count the frequency of occurrence, like how many times each word is repeating. Okay. Now, if you look at my mapper program, what I have done, well, the framework will read each line and give it to you. So you can see that first, second, third, each line is actually read. The mapper program, what it basically does, it splits each line using space as a delimiter and converts each word into a key value pair. So what I can do, I can take this line says bus, car, train, right? I can use space as a delimiter in my mapper code. So this will be divided into 3 words called bus, car, and train. And then I add 1 as the value. So this will be converted into bus, comma 1, car, comma 1, train, comma 1. Why? Because in Mapreduce, the mapper output has to be key value pair. You cannot violate that rule. Mapreduce works on the core principle of key value pair. Your data has to be in the form of key and value if Mapreduce has to run. So I'm developing a logic here. So I'm taking each line, split it using space, and then convert each word into something called word and 1, a key value pair. So you can see that each line is actually now converted into a key value pair. The second line also gets converted like this. Third line also gets converted like this. So the output of a mapper program is always key value pair, no exceptions. So what we did here is that you may be wondering, there is one more interesting thing that is happening here, which is in the third line, you had bus, plane, but the output says bus 2 and plane 1. You may be wondering that, hey, that should be, bus 1, bus 1. Why are you having bus 2? So there is a concept called a combiner in Mapreduce, which can do local aggregation. So since bus is repeating in the same line, what I did, instead of writing bus, comma 1, bus, comma 1, I aggregated the values. I said bus, comma 2. Okay, so the output of mapper is this. It's a key value pair. Once this is happening, there is a space called intermediate splitting and shuffling, this space. So this phase will happen automatically. In this step, what is going to happen is that all the values and keys will be assembled together. For example, bus is a key. There is a value called 2, then there is a value called 1. Car is a key, there is a 1 value. Train is a key, 1 value. Plane is a key, 1 value. So in this intermediate splitting and shuffle phase, the Mapreduce framework automatically brings up all the values of any given key. Finally, the developer is also supposed to write a reducer program. There is something called a reducer program. In the reducer program, you basically write an aggregation logic. So you're going to aggregate the values. So since I want the word count, I will say for every key, sum all the values. So it will add all the values for bus, then for car, then for train, then for plane, and this will be your final output. So this is your final output. So this is probably a very crude way of explaining MapReduce, but this logic is applicable to even simpler programs or complex programs. So in MapReduce, when you write a MapReduce program, what is happening? There are two programs you are writing, mapper program and reducer program. Mapper program from the original data extract the required data in the form of key and value. That is what the mapper program is doing. The reducer program will aggregate, will apply some aggregation on all the values of a given key. So MapReduce, and so this is like the mapper program is dividing the data and the reducer is conquering the data. It's like a divide and conquer situation. Now the beauty of this is why MapReduce is originally being used starting from 2005 is that your data may be spread across 100 data nodes, and MapReduce can run parallelly on 100 data nodes. That's the beauty. So if my data is on 100 data nodes, 100 mappers will be launched, each mapper producing key value pairs on one machine. So just assume that each line is on a data node. For sake of simplicity, I'm saying, so just say this line is on data node 1. Data node 1. Let's say this line is on data node 2. Why am I not able to write? Data node 2. Let's say this line is on data node 3. So in this example, I'm saying each line is on a data node, but in reality, each block can be a data node. So your mappers can run parallelly on hundreds or thousands of data nodes and produce key value pairs. Then they can be shuffled across the data nodes and the reducer can do aggregation. So this technique of MapReduce is being used to analyze huge amount of data in many places, including Hadoop. So Hadoop is one example. Even outside Hadoop, many places it is actually being used. Monica says like a dictionary, correct, right? So Shravya was saying, can you please repeat this once again? Yes. So basically you have an input file, you split the file into different lines. Then what the mapper is actually doing, it is producing key value pairs. So from each line, it is producing key value pairs. So the key I am assuming here is the word, the value is 1. Then there is an intermediate splitting phase where what happens, the values of corresponding key are brought together. In the reducer, you write an aggregate function to get the final output. But even though MapReduce is this, I should also talk to you from an industry point of view, right? See, in the industry, nobody is actually writing MapReduce program these days. MapReduce is out of the industry. Okay, so I should not sugarcoat my words, right? So don't worry, you don't have to really learn MapReduce. People stopped writing MapReduce programs in 2016. MapReduce is no longer directly being written anywhere, that I can guarantee. Then you may be wondering, why are you talking about it, right? That is because I just want to give you an overview. So if MapReduce is gone, then you may be wondering then how the processing happens. So basically Spark has replaced MapReduce. There is another execution engine called Spark, and Spark takes some of the concepts of MapReduce, but in a better way. So in the industry, when you look at it right now, people are using Spark much more. And with the invention of Spark, people stopped using Mapreduce. And we have a session on Spark where I will talk about Spark, right? So don't worry about that. In the Spark session, I will talk about it, right? Tushar says, how will MapReduce work with structured data as input? See, MapReduce can work with any kind of data as input. If you're giving structured data, let's say you're giving a CSV file, each line it will read as a record. That's all. By default, let's say you have a CSV file, okay, 1,000 lines. Then each line will be a record. Then the same step, this bus, car, train can be one line in your CSV file. So MapReduce can work on structured, semi-structured, unstructured, any kind of data. But currently, nobody is directly using MapReduce, meaning people are not sitting and writing MapReduce code these days. That I can guarantee. However, MapReduce is internally used by some other engines. So in our course, if you look at it, we have some engines like a Pig, Hive, and all. So I don't know whether you got time to go through the course curriculum, right? If you look at our course curriculum, right, there are some other execution engines. For example, there is something called Apache Hive. There is something called Apache Pig. So these guys can use MapReduce internally. So there you don't have to write a program. I'm just saying that when you're using Pig or Hive, internally MapReduce might be invoked. But nobody is writing MapReduce program as fresh from scratch. That I can guarantee. Great. Now, regarding the lab part, right? So did you guys install any VM or anything like that? Okay, so there is a question before that. There was a question, where will the shuffling and sorting take place, in name node or data node? It is always in the data node. Understand that in the name node, no processing will happen. Be it MapReduce or Spark or any engine that you are using, in the name node, there will be no processing at all. So the shuffle and sort happens in one of the data node only. Okay. So can you guys tell me whether you were given any virtual machine? Did you install something, a VM, and then you created something? Is that true? Do you have a lab platform? Do you have any lab platform? Hadoop is installed on Ubuntu. Okay, so Hadoop is installed on Ubuntu. And I think, see, Monica was asking me to unmute, but when I came back from the break, I think Monica was not there. So can I unmute you? You had a question, right? Monica, can I unmute you so that you can talk? No? Okay. Yes, so I will unmute you. I think I have unmuted you. Can you talk?
Yeah, hi, Raghu.
Yes.
Thank you so much for all the explanation that you gave. I had a question with respect to the blocks that you were explaining during data node.
Yes.
So like there was a file which was 192 KB and we were divided it into three blocks of 64 KB, right?
Right.
Okay. But in industry, this is a general application. But in industry setup, there may be hundreds of files with so many data in them, and the replication will happen. So wouldn't that affect the system in any way with respect to maybe security, with respect to the speed part of it?
With respect to security.
Security as well as the speed part of it.
See, for security, we use specific frameworks on Hadoop. For example, there is something called, I did not talk about it specifically because that's not part of your course, but there is something called Apache Sentry. Okay. So Sentry is actually your security framework on Hadoop. Basically, once you, so in any production setup, you will have this Sentry. Once you install Sentry, It will give you file level controls, access control, read write control, everything can be configured. So Sentry security is much more powerful than a firewall or even more than that. So security is 100% guaranteed, whether you are dividing into blocks or replicas or any of these things. Apache Sentry will take care of user access or who is accessing your data, where are the blocks, which machine holds it. All these things will be guaranteed by Sentry. Performance wise, yes. See, the blocks will not have any performance impact. The replication might have. To give you an idea, if let's say I'm storing a 100 GB file, I have a 100 GB file. I want to store it. With the replication of three times, you need 300 GB space. Am I correct? So this is kind of like a, I won't call it as a drawback, but it is a feature, right? Because everything replicates 3 times. So if I'm storing 100 GB, eventually I need 300 GB space. So you can actually control this. Okay, so replication is not a global factor. I can set replication individually for each file, and we do that sometimes because I was working with one of the healthcare client from US. Okay, so one of our client was kind of like a healthcare vendor from US. So in US, you know, this healthcare is very critical. Okay, healthcare domain. So wherever you are storing healthcare data, they always want 5 copies, not 3, but 5. So all those project data, we were having like 5 copies, only those data. Because the customer insisted we keep 5 data, five copies. On the other hand, if you're collecting some log messages, some data which is not really critical, I can reduce the replication factor. I can say instead of 3, you can keep it 2 or 1 even, but that might affect the data, but I can say 2. So replication, yes, you have to decide it based on the file that you're having, and you can have file level replications and all if you want. Okay. I guess that answers the question, right? Now, one more thing I want to demonstrate. So regarding the lab part, my team will get back to you. Okay, don't worry, right? See, I will be using a platform called CloudX Lab. So this is my platform for all the demos. You will be having a VM, don't worry. So you can make use of a virtual machine. I will be using a lab which is already in the cloud. Now, if you want to use this, you can use, but it is a paid setup. They give you a 1 week free trial. So probably you can make use of the free trial. What you can do, you can just come to this website called cloudxlab.com, right? And if you scroll down, there is a place where you can sign up for the lab. If I scroll down again, yeah, it says enroll now lab only. So if you want only the lab, so there is a free trial for 7 days or 1 week. So you don't have to pay any money. You can say enroll now. You get 1 week free access. I recommend this because they have a 5-node Hadoop cluster in the cloud. So basically they have a 5-node Hadoop cluster and they have everything installed. Hadoop, Spark, like hundreds of tools are pre-installed. So you don't have to do anything. You just access them and run the commands. That's all. So I will be using CloudX Lab. You can get a VM, but I encourage you to try this. If you sign up today, you will get access till next Sunday. By next Sunday, we will be finishing the course, right? If you still need to practice a little bit, you have to pay 800 rupees. So it is paid after you know what you say 7 days of trial, but my point is that it's really easy to use their platform. So let me give you an overall view of their platform so that we can also see these things in action. So far I have been talking about Hadoop only in the theory. So let me show you how do you access their platform. Once you sign up and you log on, you can go to this option called My Lab. There is a My Lab button. if you click on this My Lab, you will go to this lab details, right? So here you can see lab credentials. You will have a login username, and then there will be a password to connect with the lab, right? Now you can see 4 buttons here. There is a button called Web Console, Jupyter, Ambari, Hue. 4 things you can see. Okay, in this, Jupyter is not really required for our course. Jupyter is a notebook environment. We don't need it for our course. What we need for our course is Web Console. So Web Console is basically a command line connection to the lab. So if I click on Web Console, what will happen? Let me show you how it works. If I click on the Web Console, I can log on to the lab. It will basically ask me the username. So I can copy the username from here. This is my login name. I can just copy this and paste it here. Enter. It will also ask the password. Copy the password, type it here, enter. I am inside the Hadoop cluster now. So if you want to access the Hadoop cluster from a command line, you can use the Web Console. And this is very easy, actually, right? So this is one way. So normally when you want to run a program or write a query, you may need the command line. And this is the way we do it usually. On the other hand, if you want to access the Hadoop cluster using a GUI, graphical user interface, you can use this Hue, the last option. Web Console, Jupyter, Ambari, Hue. If I click on Hue, it will again ask you to log in, okay? So in my case, it is already logged in. One of the things which Hue allows you to do is you can upload the data to Hadoop, download the data from Hadoop. So Hue allows you to do many things, but how we will be using Hue in our course is to upload the data and download the data. To give you an idea, you can click on this drop-down menu. You can go to Files. If you go to Files, you can see a bunch of files and folders here. All this is in Hadoop. Whatever you see here, so I have a home directory in Hadoop, user Raghu Raman. This is my home directory. Inside my home directory, I have all these folders and files. So if you want to analyze a file, you can just upload it into Hue. So I can show you this. I can say new, I can create a directory. So I'm going to create a directory in Hadoop. I can say new, then a directory. Let us call this directory as, I don't know, sample data, something like this, create it. So I created a folder called sample data. It looks like Windows, right? You click on the folder, you can go inside. Now inside this sample data folder, if you want to upload any file, you can just drag and drop it. So let's say I have this CSV file called suicides. I can just drag and drop it inside this. It will be uploaded. So now this file called suicides.csv is in Hadoop. It is divided into block, replica, everything that we are seeing. It is available. See, so those things will happen behind the scenes. You will not be really able to see the where is the block, where is the replica and all, because also I don't have the admin access on this lab. But if I had the admin access, I could have shown. But you see, you just uploaded the file. That's it. It's just a drag and drop. But now this file is a single block because it is 14.7 MB. And Hadoop could have created 3 copies of this file because my replication factor is actually 3. Okay, so behind the scenes, all these things will happen. So this tool called Hue will allow you to upload the data and download the data. That is a primary purpose, even though it can do many other things. Okay, so Web Console we have seen, Hue we have seen. There is also one more thing called Ambari. This Ambari is not used by developers, or in our course, we don't have to actually use Ambari. Then what is the purpose of Ambari? Ambari is used by the administrator to monitor the cluster. So if you are a Hadoop administrator, right, then what will you do? So there is somebody called Hadoop administrator and Hadoop developer. Hadoop developers are people who write programs and run programs and see the output. Hadoop administrators are the people who manage the cluster, like adding new machine, removing machine, adding user, removing user, adding extra tools. So if you are an administrator, you can use this tool called Ambari. And I can show you Ambari. We have only read-only access because CloudX Lab is a shared environment. So I can just show you Ambari. I can just click on Ambari. It will ask me to sign in. And once I sign in, let it load. This is my Hadoop cluster. See, you can see data nodes live. Can you see the second box? Data nodes live 5 out of 5. So there are 5 data nodes in our cluster. HDFS disk usage, 79%. Name node, you can see here name node, right? So there is name node running. So here you can see all the services. For example, I can go to HDFS service. It says name node started. Can you see? It says data node started. 5 data nodes started. See, 5 data nodes are there. 1 name node is there. And if you click on the name node, it will take you to the machine which is running as name node. That is not important, but in the HDFS side, we can see there is name node which is running, 5 data nodes are running, and you can also see the disk usage. 973 GB of data is there on Hadoop. 973 GB. You can also see how many blocks are there, total blocks. Very interesting. So in this cluster, total of 2,76,530 blocks are there, right? So you can see all this information from Ambari. So Ambari is nothing. I don't see the name node UI, otherwise I could have shown you that. No, the name node UI is not available, but that's okay. You can see name node is running, data node is running, all these things. You can go to Yarn. This is Yarn. You see resource manager started, node manager started. So this is the Yarn details. You can also see Mapreduce here. So Mapreduce is installed. Then there are a bunch of other tools like Tez, Hive, HBase, Pig, Scoop, Oozy. These are all Hadoop ecosystem tools or part of your Hadoop. So Ambari will give you an overall view of the cluster and tell you what is happening. Let me see if I can show you something else. Files view, if I go, give me one moment, okay? One moment, okay? So I want to show you something. Where is that folder we created? Sample data. Suicides. Do you have any details for this file? I don't see any details. Or if I open this, no, that's okay. So I was thinking whether I'll be able to show you the details of this. No. So, but that's okay. So Ambari basically gives you an overall overview of the cluster. And if you are an administrator, you can use Ambari to add machine, remove machine, change services, etc., etc. All these things can be done using Ambari. Okay. Any questions from today's class? Now I want to talk about the next topic. So if I look at my schedule, let's say, so today this was the schedule, Introduction to Hadoop Ecosystem. That is what we discussed right now. So the next session is going to be on 11th May. Okay. So on 11th May means tomorrow. So tomorrow we are going to have a session from 7 to 9 p.m. Okay. And tomorrow we will be talking about Apache Pig. There is something called Apache Pig. So it is written as an ETL tool in Hadoop, Well, ETL tool in the sense it is a tool we use to clean the data. So we will talk about Pig architecture. There is a practical of case study on IPL data. So all these things we will be covering tomorrow. And today I did not write any programs or run any programs. I will do that in the next class, right? And while doing that, I will also be sharing the code and data, everything with you, whatever I'm doing for Pig or Hive or any of these things. So tomorrow we will, tomorrow evening we will be continuing with, Apache Pig. Let me know if you have any questions. I can pick it up. Prasanna says, is replication factor maintained by secondary name node? If not, what is the role of secondary name node in case of data node failure crash? Okay, so that is a good question. See, Prasanna, we no longer use secondary name node. There is something called standby name node. So you have something called active name node and something called standby name node. Secondary name node, you can use it, but it is a very old concept. In production, we never use something called secondary name node. We use something called standby name node. What is this purpose of standby name node? If the active name node goes down, immediately this standby name node will take over. So you have high availability in the system. See, name node is the master, right? So if that goes down, then your entire cluster will go for a toss. I don't want that. So I can set up something called a standby name node, another machine, so that if my active name node crashes, this guy will take over. And replication factor is maintained across the cluster. It is not maintained by the name node alone. Every machine will maintain that as a copy. So even if your active name node crashes, the standby takeover, it will remember what is the replication factor you had in the cluster. Okay. Good question, by the way. Any other questions? Were you guys able to follow today's class? Were you able to understand today's class? Yes? Yes, thank you. All right. So tomorrow, so let us continue tomorrow. So tomorrow we will be looking at analyzing the data. So today we did not do any data analysis. Tomorrow what we will have a look at analyzing the data, and I will introduce a tool called Apache Pig to you. Apache Pig is one of the tool which we use for data cleaning and analysis on big data. So we will look at some basic commands in Pig, and then we will pick up a data set, and then we will analyze it using Pig. So we have only 2 hours on Pig, so we will be touching on some very basic concepts in Pig, and I hope we will be able to understand and continue. Now, you don't have to sign up for CloudX Lab for tomorrow. Yukta, you can even do one more thing. You can complete the whole course and then sign up as well. Because anyway, CloudX Lab will be available for only, let's say, 1 week free, right? So whenever you want, you can sign up. The free access will be only for 1 week, okay? Great. So I think probably we can wind up today, guys. We will continue tomorrow, right? Let's wind up for today. So if you have any questions, you can stay back. Otherwise, you are feel free to drop off from the webinar. Thank you.